The fragment of steel lay beneath the hanging lamps like a relic from another planet. It was warped, scorched, and half embedded with soil from the shattered field outside Aachen. Around the table, in the cold laboratory of Waldlager Kummersdorf, stood men whose profession was certainty, artillery engineers, metallurgists, and physicists accustomed to solving problems with equations and instruments. Now, they faced a mystery that smelled faintly of burnt cordite and humiliation. The object was not German, it was American. Hauptmann Ernst Vollmer, an artillery officer recently withdrawn from the Western Front, stood stiffly with his arm in a sling. The wound was healing, but his pride was not. 2 weeks earlier, his battery of 105mm howitzers had been erased by counterbattery fire before their fourth salvo. He had watched the shells land with surgical precision, marching across his gun line in an even rhythm that no random chance could explain. The first impact hit the command truck, the second bracketed the third gun, the fourth found the ammunition pit. The entire engagement lasted less than 4 minutes. He had fired, and then he had been answered by mathematics. Opposite him stood Doctor of Engineering Helmut Krüger of Wehrprüfwehr, the Army Weapons Office branch responsible for artillery science. His face was lean, grey, and expressionless, the face of a man who had long ago replaced passion with precision. On the table beside the shell fragment lay calipers, micrometers, and a cutting torch still faintly smoking from the last dissection. The overhead light hummed with the same monotone despair that filled the air. "Priority red," Krüger muttered, reading the order that had summoned him. "Immediate technical evaluation of captured American ordnance. Determine cause of superior effectiveness." He exhaled through his nose, as if physics will yield to command tone. Vollmer said nothing. He had seen his gunners torn apart by invisible fire. Words were useless. Krüger turned the shell fragment in gloved hands. Even in its deformed state, the metal told a story. He ran his finger along the copper driving band, still half attached to the steel jacket. The grooves from the rifling were clean, evenly spaced, the scoring shallow and symmetrical. There were no burrs, no tears, no evidence of gas blow-by. It was a perfect engraving, the mark of a shell that had spun true through the air before detonation. German bands, even at their best, left scars like torn parchment after firing. By late 1944, copper impurities and zinc substitutions had made them brittle. But this was precision born of abundance. He lifted the sample toward the light. "Uniform hardness," he murmured. "Consistent across the circumference." He gestured for the lab assistant to take readings. "Note the engraving depth, 1.2 millimeters, constant." He set the caliper down, and for a moment simply stared at the fragment. "Do you see, Herr Hauptmann? It is not only the gun that matters. It is the repeatability of the gun, the shell, and the man who loads it. They have achieved industrial precision that no longer depends on craftsmanship. Their factories build accuracy by the thousand." Vollmer rubbed the scar on his wrist. "You mean they do not miss because they do not need to aim?" "I mean," Krüger said quietly, "that their aim begins in the factory. Around them, the rest of the engineering team moved through the ritual of measurement density tests, thread pitch verification, metallurgical sampling. Each number came back the same, flawless machining, exact tolerances, no deviation beyond a fraction of a millimeter. In another context, it would have been admirable. Here, it was terrifying. Krüger flipped through the frontline report accompanying the sample. It described the destruction of an 88mm anti-aircraft battery that had been firing in a ground roll near Aachen. According to the surviving crewman, the first American shells arrived less than 180 seconds after his unit opened fire. The observers had barely completed their spotting corrections before the counter-battery barrage obliterated them. "We have never seen such reaction time," the report concluded. "It is as though the enemy's guns already knew where we were." 3 minutes, Vollmer said softly. "That is not reconnaissance. That is mathematics." Krüger looked up. "Sound ranging, flash spotting, fire control computers, perhaps yes. But the timing, the precision of elevation and charge, those require consistency of material. If one shell is faster or slower, one fuse more sensitive than another, the entire calculation fails. They have solved that, we have not. He placed the fragment under the microscope. The polished cross-section revealed concentric crystal structures frozen by exact heat treatment. See this, he told the others. Austenitic grain boundaries perfectly aligned, no impurities, no voids. Each shell identical. You could swap any one for another, and your dispersion pattern would remain the same. That, gentlemen, is how you build accuracy without genius. The younger engineers scribbled notes, some wide-eyed, others resentful. To admit superiority was treason to morale. Yet even the most loyal could see the truth beneath the microscope lens. The steel told no lies. Outside, the winter wind hissed through the pine forest that ringed Kummersdorf. Somewhere beyond the tree line, the muffled rumble of distant artillery rolled across the cold air, an echo from the Western Front, where men were dying under the same physics they studied here. Vollmer flinched at the sound. Krüger did not. Once, Krüger said after a long silence, our guns ruled battlefields through calculation and discipline. Our fire plans at Sedan, at Kiev, at Sevastopol they were, masterworks of coordination. But now we are fighting an enemy who has turned calculation into automation. They have built the equation into the machine. Vollmer's voice cracked. You speak as if the war is already lost. Krüger kept his eyes on the fragment. For the artilleryman, it may already be. What can courage do against a table of logarithms and an assembly line? He reached for the next piece, a portion of fuse thread. The threading was cut to such uniformity that the pitch error measured less than 1 part in 1,000. He knew what that meant. Every fuse, every detonator, would seat precisely, ensuring that time settings and impact delays performed as designed. The Americans could rely on their calculations because their metal obeyed them. The Germans could not, because their alloys now lied with every heat and batch. He wrote a note on the margin of his worksheet. Precision is their doctrine. Then another. We cannot replicate under blockade. Vollmer leaned closer. If we had this metal, could we match them? Krüger shook his head slowly. Metal is only one part. You would need their propellant consistency, their range tables computed with electronic calculating machines, their transport network that delivers shells faster than we can fill orders, their weather reports transmitted by radio to every battery. You would need their fuel, their copper, their factories that do not sleep under bombers. You would need, Herr Hauptmann, an America. The room fell silent except for the scratching of pencils. In the corner, the laboratory clock ticked toward midnight. At last, Krüger set down his tools. He removed his spectacles and rubbed the bridge of his nose. They will ask me for countermeasures. I will write that we must improve propellant uniformity, refine driving band alloys, and tighten manufacturing tolerances. He replaced the glasses and looked at Vollmer with eyes dulled by exhaustion. But even if we begin tonight, it will take years. The war will end before the machinery arrives. Vollmer studied the misshapen fragment one last time. It had killed his men, and yet it gleamed with the cold beauty of perfection. Then what do I tell the soldiers, Herr Doctor? Krüger's answer came without hesitation. Tell them that physics is impartial. It serves whoever feeds it better data. The laboratory lights flickered as a generator coughed outside. Somewhere far away, the deep thunder of Allied artillery rolled again, faint but steady the sound of equations being solved. The smell of oil and graphite hung in the testing gallery at Kummersdorf as Dr. Helmut Krüger stood before the chalkboard. Equations covered it like frost parabolic trajectories, muzzle velocities, angles of elevation, and air density corrections. A dozen engineers sat on wooden stools, their uniforms wrinkled, eyes rimmed red from lack of sleep. On the table behind them rested 2 shells, one German, one American. They were the same caliber 105 millimeters, but they belonged to different centuries of thinking. Krüger tapped the chalk against the board. Range, he said, is not courage. It is calculation multiplied by consistency. He drew two curves on the black surface. Our standard howitzer, the 10,5 cm leichte Feldhaubitze 18, reaches roughly 10,600 meter with a full charge. On paper, adequate. In practice, under battlefield conditions, our dispersion radius at that range exceeds 200 meter. At 12 km, we are no longer accurate, we are statistical. Paused, turned, and gestured to the American shell. There's M2A1's 105 mm fires to 11 km with routine accuracy under any climate. Their gun crews fire by table, not by instinct, and their tables are flawless because their shells are identical. The men murmured, some in disbelief, some in reluctant awe. Hauptmann Vollmer, seated near the door, spoke quietly. They outrange us, yes, but we've seen long-range guns before. The French tried it at Verdun. Krüger shook his head. You misunderstand. It is not range alone that matters, it is control of range. Observe this. He unrolled a captured American firing chart, printed in neat columns, laminated against moisture. Notice temperature corrections every 5 degrees, propellant lot numbers, humidity coefficients. Every battery receives identical data, transmitted by radio. Each shell's velocity deviation is less than 1 part in 1,000. Their gunners can calculate a trajectory to strike a truck 2 kilometers beyond the limit of our own tables. That, gentlemen, is the difference between artillery as craft and artillery as science. He drew another line beneath the first pair of curves. And then there is the heavy gun, the 155 mm long Tom, effective range 22 km, accuracy within 50 meter at maximum. With that, they can destroy our batteries before we are even within reach. One of the younger officers, Oberleutnant Hirsch, frowned. Surely, Herr Doctor, they must wear out barrels faster. That kind of propellant load cannot be sustained. Krüger smiled faintly. Indeed, they do. But they replace barrels as easily as we replace tires. Their factories build spare tubes in advance, and their logistics deliver them by the trainload. We, on the other hand, debate whether a new liner merits allocation of molybdenum. He returned to the chalkboard and underlined a word: repeatability. Our fire tables depend upon a concept we can no longer afford: craftsmanship. Every shell, every propellant bag, every fuse is the product of a craftsman's hand, and thus each differs slightly. A fine system for an empire of abundance, but not for a starving fortress. They have replaced craftsmanship with precision manufacture. The mathematics of their range begins in the lathe. Vollmer studied the two shells on the table. The German casing bore tool marks, slight irregularities at the band edge, faint scoring where the copper had been seated by hand. The American shell looked machined by geometry itself, polished, balanced, indifferent. Our gunners say the Americans never waste a salvo, he murmured. They adjust once, then annihilate. Krüger nodded. Because their first salvo is already an adjustment. Each gun in a battalion fires to identical range, each shell flies the same curve. Their dispersion forms a mathematical ellipse, predictable to the meter. Once the observer reports the error, the next salvo is perfect. This is not luck. It is industrial standard deviation at war. A pause. Outside, the wind rattled the shutters, carrying faint echoes of thunder from the proving range. Consider propellant stability, Krüger continued. Our charges, produced under blockade, contain variable nitrocellulose content. Humidity and age alter burn rate. A difference of even 0.5% changes muzzle velocity by several meters per second. At 15 km, that error becomes a miss of 50 meter. They suffer no such uncertainty. Their powders are chemically stabilized, their charge bags sealed with waxed liners. Even after a year in tropical storage, their velocity variation remains constant. When they compute a range of 15 km, they strike 15 km. He turned to the audience, his voice low but urgent. This is why their counterbattery fire arrives before ours. Their observers triangulate our muzzle flashes, compute coordinates, and within minutes the fire direction center feeds range, bearing, and charge to a dozen guns. Each gun, no matter its crew, will deliver precisely the same flight time. The mathematics close the loop faster than human reflex. Once you fire, your position becomes an equation in their system. And they solve. Equations faster than we can move guns. Vollmer rubbed his temples. So even when we camouflage, they find us? Not through sight, through sound. They have arrays of microphones stretching kilometers apart, each wired to a central plotting room. The delay between sound arrivals gives range and azimuth. Our own sound-ranging units worked well in the last war, but now we lack copper wire, batteries, even paper for charts. They have unlimited supply. Unlimited precision. A bitter laugh escaped one of the engineers, and we thought the war would be decided by tanks. Krüger's gaze hardened. Tanks win battles, guns win wars. Ask Napoleon, or Foch, or Zhukov. He who controls range, controls time. The Americans have stolen both. He stepped away from the board, fatigue shadowing his face. Gentlemen, we are not merely losing ground, we are losing the laws of motion. Newton fights for them now. Vollmer rose, his boots scraping the floor. Then tell me, Doctor, can we fight back? Build longer guns, stronger propellants? Krüger's reply was quiet. You cannot build range without steel, nor precision without copper, nor mathematics without machines. We are out of all three. Silence. The only sound was the faint ticking of the range clock. Krüger picked up the American shell and weighed it in his palm. They have turned abundance into geometry, he said finally. Every explosion on the front is the echo of a factory somewhere in Michigan or Illinois where a machine cuts steel to the same depth every time. That is their doctrine consistency as a weapon. He set the shell down gently, as if placing a child to rest. Gentlemen, the mathematics of range are no longer ours. Outside, thunder rolled again from the west, not the sky's thunder, but the slow, methodical pulse of distant American guns, each detonation another proof of an equation solved correctly. The men in the laboratory stood listening. No one spoke. They all understood that the sound they heard was not simply artillery. It was the sound of precision defeating passion, and of a war being measured meter by meter, shell by shell, until the equations themselves ran out of enemies to solve. The laboratory smelled of scorched metal and acid. Copper shavings glittered like orange dust across the benches. Dr. Helmut Krüger leaned over the metallographic microscope, eyes half closed, tracing the grain lines of a captured American driving band. Outside, the pine forest was heavy with snow, but inside Kummersdorf the air was hot, dry, and stifling the heat of defeat disguised as scientific rigor. Around him, his team of ordnance technicians moved quietly, afraid to speak too loudly. Every sound, the hiss of the acetylene torch, the soft clack of calipers echoed in the hollow room. The copper band under Krüger's lens was no larger than a coin, yet it contained an empire's secret. "Look here," he said, motioning Hauptmann Vollmer forward. "See these grooves? The rifling marks are shallow, evenly cut, no tearing, no galling. The copper flows perfectly into the lands." Vollmer squinted through the eyepiece, blinking. "It looks too smooth. Ours never come out like that." "Exactly," Krüger replied. "Theirs do, every time." He placed two fragments side by side on a white cloth. The German sample from a 10.5 centimeter shell fired last month looked jagged, uneven, the copper twisted like ribbon. The American fragment gleamed, its engraving clean as a fingerprint. "Our alloy," Krüger explained, contains inconsistent zinc content. Shortages forced substitutions. When the barrel temperature rises, the band begins to shear, and gas escapes around the edges. We lose pressure, we lose range, we lose accuracy. Vollmer frowned. "And theirs?" "Controlled to a fraction of a percent. The hardness profile is constant from core to rim. They can fire at maximum charge, repeatedly without stripping the rifling. Their barrels stay sealed. The projectile exits straight. Ours wobble. He took up a thin chisel and sliced the band in half. The cross-section revealed layers of fine metal, each with a uniform texture. "See this pattern?" he said softly. "It means homogeneous casting. No bubbles, no cold joints. Their rolling mills produce copper-like glass." One of the younger engineers, Unteringenieur Faber, spoke from the corner. "We could achieve the same if we had pure copper." Krüger turned toward him. "And where will you find it, Faber? The mines of Africa? The shipments from Spain? Even our telephone wires are being melted into shell bands. Purity is a luxury of victors." He straightened, his face pale under the harsh lamp. "This is what war by exhaustion means. We substitute brass where they use copper, iron where they use brass, hope where they use data." Vollmer said nothing. He had heard the frontline complaints for months: shells that jammed in the breach, guns that lost accuracy after a dozen shots, barrels that wore smooth before the campaign was over. But hearing it spoken in the language of science gave it weight beyond rumour. Krüger handed him a printed chart. "Hardness readings," he said. "Ours vary between 55 and 70 on the Brunel scale. Theirs always 63, plus or minus 1. That is not luck. That is production control." He gestured to the test stand at the far end of the room. "We fired 5 German shells and 5 American shells from the same captured barrel. Measure the dispersion." Vollmer bent over the chart. The German pattern spread like a handful of gravel tossed onto a field. The American one formed a neat, circular cluster, smaller than a farmhouse. "At 10 kilometer, Krüger said, "that means the difference between suppression and annihilation." He paused, then added, "We once thought war was an art. They have made it an equation." The door opened suddenly, bringing in a gust of cold air and the sound of distant gunfire from the proving ground. A courier entered, his uniform flecked with snow. "Herr Doctor," he said, saluting. "Message from Berlin. Priority red." Krüger took the paper and read silently. His jaw tightened. "They want to know," he said bitterly, "why our shells are less accurate than the enemy's, and what immediate remedy I propose." He looked around the room. "Immediate, as though metallurgy obeys deadlines." He crumpled the message and tossed it into a waste bin already full of unanswered orders. Vollmer watched him. "What will you tell them?" "The truth," Krüger said, "that we have reached the edge of physics, that no discipline can survive without resources." He moved back to the microscope, his hands trembling slightly. "Do you know what this means, Herr Hauptmann? They have achieved what we once considered impossible, industrialized precision. They no longer rely on the craftsman's touch or the officer's intuition. Their machines think for them, and they never grow tired." Faber muttered, almost to himself, "Machines cannot win wars." Krüger looked up sharply. "No, but they can end them." He motioned for the technicians to bring the hardness press. They clamped another sample beneath the anvil. The dial needle moved, stopped, and held steady at 63. Another sample again 63, and another, every test identical. Krüger whispered, "Statistical perfection." Then, louder, "Gentlemen, this is why our counterbattery fails. Every one of their shells behaves predictably. When their observers call a correction, the next volley lands exactly where it should. We, however, must guess how our shells will fly today, a different pattern every batch. How can mathematics guide artillery when its variables refuse to stay constant?" He wrote the words, "industrialized precision," on the board, underlining them twice. Outside, the generator coughed and sputtered. The lights dimmed, then steadied again. The room seemed smaller now, as though the walls themselves understood the conclusion forming in every mind. Vollmer finally broke the silence. "When I commanded in Russia, our guns were gods. Now, every time we fire, I feel as though we are exposing ourselves to execution. Their answer comes faster, cleaner, deadlier. I thought perhaps it was luck. Now I see it is simply order, and order favors those who can afford it." Krüger nodded slowly. They have mastered uniformity. We improvise, they produce. He looked down at the copper, glinting under the lamp, its surface shining like blood in the light. In the end, Herr Hauptmann, the war may be decided not by soldiers or generals, but by whoever learned first how to make copper obey. The men said nothing more. In the distance, thunder rolled again, not the sky's thunder, but the low, rhythmic pulse of guns working according to perfect mathematics. Each shot was the sound of a machine speaking the language of certainty, while the tired scientists of Kummersdorf listened and understood that the argument was already lost. The proving range at Kummersdorf stretched out beneath the grey November sky, scarred by craters and half-frozen mud. It was here that Germany's greatest promises were tested, and where, now, the limits of her decline were measured with each echoing gunshot. Dr. Helmut Krüger stood at the observation bunker beside Hauptmann Ernst Vollmer, both men shivering under heavy coats. Before them, a captured American M191 howitzer stood on its firing platform, freshly painted in German field grey. Beside it, the crew of engineers prepared the gun for firing part of an experiment no one wanted to admit had been ordered by desperation. The plan was simple. Replicate American firing tables using German mathematics. If the shell struck within 100 meters of target at 10 to 15 kilometers, the test would be declared encouraging. Encouragement, Krüger thought, was now measured in meters missed rather than targets hit. The gun captain raised his hand. Fürbereit. Krüger nodded. Fire. The thunder cracked across the range. The ground trembled, smoke billowed upward, and the shell disappeared into the overcast horizon. Seconds stretched into silence until a distant thud rolled back through the air. A spotter's voice came over the field telephone, clipped and uncertain. Impact. 260 meters long, 100 right. Krüger exhaled sharply. 260, he repeated. That is 200 too many. Vollmer crossed his arms. Our calculations were exact. Then the world itself is betraying us, Krüger replied. Or our powder. They returned to the bunker, where sheets of data waited. Krüger spread them across the table: temperature, pressure, elevation angle, propellant batch number. Every variable accounted for, yet the error persisted. He drew a line through the firing log. We cannot model chaos with outdated constants. He turned to Vollmer. Their firing tables are dynamic. Ours are static. We pre-compute and pray the weather stays loyal. They measure, compute again, and fire within minutes. Their command posts are laboratories. Ours are monuments. He pointed to a photograph pinned above the desk, an American fire direction center captured near Saint-Lô. In the picture, soldiers hunched over machines, slide rules, barometers, electric rangefinders, even portable calculators connected to field telephones. This, Krüger said, tapping the image, is their true artillery. The gun is only the final instrument. Vollmer frowned. We have range tables too. Yes, Krüger said quietly, printed in 1939, for a world that no longer exists. He took a piece of chalk and began sketching on the concrete wall. Range is a function of velocity, elevation, and air resistance. But each variable changes with temperature, humidity, and barrel wear. To account for that, one must calculate new corrections for every salvo. Our officers do this by mental arithmetic. Theirs use electric computation devices. They can calculate in 30 seconds what takes us 5 minutes. 5 minutes, Herr Hauptmann, is the difference between counterbattery survival and annihilation. He wrote numbers faster, the chalk squealing. T equals distance divided by velocity. Delta from propellant degradation. Delta theta from barrel erosion. They have reduced artillery to pure time, Krüger continued. Each fire mission is an algorithm. Detect, compute, deliver. The mathematics flow faster than human thought. Their radar detects muzzle flash, the coordinates feed directly into firing centers, and within 180 seconds the reply arrives. No emotion, no hesitation. It is the language of machines. Vollmer watched him, uneasy. You speak as if you admire them. Krüger lowered the chalk. I respect inevitability. Physics favors organization. They obey its laws more faithfully than we do. He motioned to an aide. Bring the propellant samples. On the bench lay 2 canisters, one labeled 91, a American origin, the other Sprengladung 3, German. The difference was visible even to the untrained eye. The American grains were uniform, pale, each the same length and diameter. The German powder varied in color, clumped from humidity. Krüger poured a few granules onto a metal tray and ignited them. The American powder burned with steady, controlled flame. The German burst unevenly, sputtering like a candle in wind. That, Krüger said, pointing, is why our muzzle velocities wander. Even perfect gunnery cannot defeat imperfect chemistry. Vollmer leaned closer. Can we replicate their formula? Krüger shook his head. We lack the stabilizers, the pure ether, toluene. Our refineries are rubble, our rail lines broken. We cannot produce consistency under siege. He paused, then added quietly, but we can understand what consistency means. He moved to the next chart, ballistic flight curves plotted from recovered American data. Notice how their dispersion shrinks with range, he said. Counterintuitive, yes? But that is the effect of consistent propellant and fusing. Their shells follow almost identical arcs, so statistical error cancels itself. Ours diverge because each shell flies its own path. A long silence filled the bunker. The men stared at the lines, one tight and perfect, the other scattering like shrapnel across the paper. Vollmer finally spoke. When I was a cadet, they taught us that artillery is the god of war. Krüger looked up. Then we are priests who have lost our scriptures. A technician entered, holding a new report. Herr Doktor, new impact data from the second round. Krüger took it. Range? 17 meters long, 3 left. He blinked. 17! Yes, Herr Doktor. Used American propellant with captured gun. For the first time in days, Krüger smiled, not from triumph, but from understanding. You see, Herr Hauptmann, it is not the gun that wins. It is the powder, the copper, the mathematics, the entire civilization behind the shell. Give me their resources, and I will give you their accuracy. He placed the paper gently on the table. We can copy their formulas, but not their factories. We can measure their precision, but not mass-produce it. That is the limit of our genius. Vollmer stared out the narrow bunker slit toward the grey horizon. Snow was beginning to fall, silent and indifferent. So the difference, he said quietly, is not courage or training, but calibration. Calibration, Krüger repeated. The Americans have calibrated the world. He turned off the lights above the test table. The last glow of test, the shell's impact still shimmered on the horizon, a faint flicker through the falling snow like the after-image of inevitability itself. Krüger gathered his papers. The war will not end because our soldiers break, he said. It will end because our equations no longer balance. Outside, the next gun fired, and the echo rolled back across the frozen fields, not as a roar of defiance, but as an answer already written in the mathematics of defeat. By late November of 1944, the laboratories at Kummersdorf had turned into something between a morgue and a monastery. Every bench was crowded with dissected fragments of steel-cut sections of gun barrels, twisted breech rings, deformed shells. Each piece bore the scars of exhaustion, as if the metal itself had fought too long and wanted only rest. Dr. Helmut Krüger stood before a furnace glowing dull red. He was thinner now, the collar of his tunic loose at the throat. Hauptmann Ernst Vollmer joined him, holding a report from the front. Our long-range batteries at the Rohr River are gone, Vollmer said quietly. Counterbattery again. They located and destroyed 3 positions in under 4 minutes. Krüger didn't look up. 4 minutes, he repeated. The time it takes us to light a cigarette, aim, and die. He opened the furnace door and withdrew a steel sample clamped in tongs. The metal shimmered, heat rippling in the cold air. "Observe," he said. "This is Krupp steel, the pride of Essen, forged to withstand 12,000 atmospheres of pressure. Yet, under repeated firing, it yields after 800 rounds. The Americans' ordnance steel lasts over 1,500, twice the lifespan. Do you know why?" Vollmer shook his head. "Because their steel remembers its shape," Krüger said, setting the glowing piece on an anvil. "They use a process called vacuum induction. Melting removes hydrogen and sulfur completely. Our furnaces are open to air. Impurities remain, grain boundaries weaken. Under pressure, microfractures grow until the metal forgets its purpose. Our barrels die of fatigue, not impact." He tapped the metal with a hammer. It sang faintly, a high, brittle note. "Hear that? It should ring deep, resonant. This is a tired sound. It's the voice of steel that knows it's already failed." Across the room, an assistant placed a captured American barrel section on another stand. The contrast was immediate. The inner surface gleamed mirror-bright, its rifling crisp, unburned by heat erosion. Krüger ran a gloved finger along the grooves. "Chromium lining," he murmured. "Microscopic, but enough to double service life. They can fire longer without accuracy loss. We proposed this in 1941, but chromium was reserved for armor plate. We traded endurance for tanks, and now both are dying together." Vollmer unfolded another report. "The General Staff wants recommendations for prolonging barrel life." Krüger laughed softly. "Tell them to stop firing." He turned back to the workbench, where under magnification the cross-section of a worn barrel looked like the terrain of a ruined world, fissures, craters, ridges where heat and pressure had eaten into the grain. "Metallurgy," he said, "is memory. Each round writes its own history in the steel. Their history is smoother, ours chaotic." Vollmer studied him. "You speak as if the metal itself has chosen sides." "In a way it has," Krüger said. "Physics serves whoever obeys it most faithfully. We bent the laws, they refined them." He gestured toward a chart pinned to the wall. Elastic modulus versus yield fatigue, US versus German alloy samples. The American curve was smooth, predictable. The German one jagged, descending erratically. "This is what exhaustion looks like," Krüger continued, "not only in steel, but in nations. Once, we made the finest instruments of war. Now, we improvise, with scrap metal and superstition." Outside, a deep rumble rolled across the forest, distant artillery from the west. Each pulse was a reminder that science had become a battlefield all its own. Vollmer leaned against the table. "My men still believe if we build something bigger, we can turn it around a heavier gun, a new wonder weapon." Krüger's expression hardened. "Bigger only means slower. Power without precision is noise. They have achieved the opposite smaller deviations, predictable energy. Their barrels speak in decimals. Ours shout in chaos." He paused, staring into the furnace again. "When the Americans fire, their guns breathe in harmony, identical recoil, identical velocity, identical echo. It's not just engineering. It's discipline written in metal." The assistant approached hesitantly. "Herr Doctor, the Reich Ministry requests an urgent summary for Berlin. An evaluation of enemy shell performance and recommendations for counter-design." Krüger sighed, took a pencil, and wrote across the top of the page in neat block letters, "Recommendation. Build another planet." Then, after a long moment, he crossed it out and began again, slower, deliberate. 1. Impurities must be eliminated from all gun steel. 2. Chrome lining necessary for sustained fire. 3. Chemical uniformity in propellant and driving bands mandatory. 4. Without industrial scale and resource stability, these measures remain theoretical. He handed the paper to the assistant. "Send it. They will file it and forget it. Truth is an element rarer than tungsten." Vollmer picked up one of the American fragments and turned it in his hand, the polished steel catching the lamplight. "Strange," he said quietly. "It looks almost beautiful." Krüger nodded. "Because it was made without fear." He stared at the glowing barrel section cooling on the stand, faintly humming as it contracted. "Steel remembers how it was born," he said. "Ours remembers fire and hunger, theirs remembers order." And outside, as the snow began to fall across the frozen testing ground, the distant thunder of American guns continued a steady, mechanical rhythm, as if the world itself were reciting the new language of warfare, the poetry of precision written in steel. Snow lay in grey ridges around the Kummersdorf test complex. The chimneys coughed black smoke against a sky the colour of lead. Inside, the laboratories were quiet except for the tapping of typewriter keys and the faint hiss of furnaces keeping the last experiments alive. Dr. Helmut Krüger stood before a newly arrived crate stamped U.S. Army Ordnance Department, Pittsburgh plant. Its contents had been captured near the Hürtgen forest, sections of shell casings, propellant samples, and something far more important, the manufacturing data plate from an American munitions factory. The plate was nothing more than a sheet of aluminum, etched with a series of numbers and letters that only engineers would notice. But to Krüger, it was a revelation. "Look," he said to Hauptmann Ernst Vollmer, who was watching from across the table. "Each shell batch is serialized not by date but by production line and heat lot. Every cartridge can be traced back to its furnace, its shift, its inspector. That means they can isolate an error before the next shipment even leaves the factory." Vollmer frowned. "You mean they track each shell individually?" "Yes, they track consistency. It is as though their factories think like mathematicians. The quality control is not human anymore, it's systematic." He ran his fingers over the etched numbers, whispering them aloud like a prayer. "Line 7, batch 392A. Inspector KL. Even the initials are standardized. They have transformed manufacturing into a language of certainty. We cannot even guarantee the same hardness between two neighboring shells." He moved to a map on the wall showing industrial centers across America: Pittsburgh for steel, Bridgeport for powder presses, Hartford for fuse mechanisms, Detroit for machining. Each city is a node in an equation that ends at the gun barrel. When the Americans fire, they are not one army, they are an assembly line stretching from ocean to ocean. Vollmer said nothing. He had seen the results firsthand: batteries annihilated in seconds, positions buried under perfectly timed salvos. He had once believed those attacks to be the product of overwhelming numbers. Now, listening to Krüger, he realized they were the product of overwhelming organization. "Do you see?" Krüger continued, his voice low but urgent. "We still fight as craftsmen. They fight as engineers. We adjust our guns by feel. They adjust their factories by formula." He lifted an American shell section from the crate and placed it beside a German equivalent. The difference was surgical: smoother finish, cleaner threads, sharper angles. "Every operation performed by a machine calibrated by another machine," he said. "That is why their shells fit perfectly, their fuses never jam, and their range tables always match reality. They have achieved something we once thought impossible: mechanical infallibility." An engineer entered, carrying a new report. "Herr Doctor, our test of the American fuse M104 is complete. Results? Detonation reliability, 99.9%. Tolerance deviation, 0.2 mm. Our comparable Z23 model," Krüger interrupted softly, "fails 12% of the time. Yes, I know." He dismissed the man with a nod and turned back to Vollmer. "Do you know how they achieve this?" "How?" "By refusing to trust chance. Their inspectors measure not every 10th part, but every part. Automated gauges, electric comparators, photographic calibration processes we abandoned because they seemed too slow. Yet they build faster than we do, because errors never return to haunt them. Their precision accelerates production. Our improvisation slows it." He paused, staring into the distance as if trying to see across the ocean. "Imagine an assembly line 2 kilometers long, each worker guided not by instinct but by instruments. At the end of that line, a shell rolls off, identical to every other. When fired from New York or from Normandy, it will fall at the same angle, strike with the same energy, burst with the same delay. That is not industry, that is replication on a divine scale. Vollmer glanced around the lab, where aging German lathes hummed tiredly, their belts slipping, their bearings worn. "We once built the finest machinery in the world," he said bitterly. Krüger nodded. "And we still do, one masterpiece at a time. They build mediocrity by the million, but their mediocrity obeys mathematics." He reached for a small steel dial on the table, apart from an American automatic lathe. This device alone replaces 20 machinists. It measures, adjusts, and corrects every rotation. It never sleeps, never forgets. That is the true weapon of this war, not steel or fire, but feedback. Vollmer tilted his head. "Feedback?" "Yes," Krüger said, eyes gleaming. "A machine that measures itself and corrects itself faster than a man can think. Apply that to artillery production, and you no longer rely on gifted workers, only on process. That is why their artillery grows stronger, while ours grows brittle. Their war is not fought on the battlefield first, it is won in the foundry." He tapped the factory plate again. "Each number, each code, each name etched here represents a decision made months before the battle. When their shells landed on our gun lines outside Aachen, the battle had already been decided in Pittsburgh, in Hartford, in Detroit." He turned toward Vollmer, his face illuminated by the furnace glow. "Do you know what this means? Their front begins in the factory. The artillery is merely its voice." Outside, a truck rumbled past, hauling crates of test ammunition, German hastily welded, corners rough, stenciled letters already flaking. Krüger watched it go. "They have made their factories extensions of their minds," he said. "We still treat ours as workshops." Vollmer's voice was quiet. "And if we could match them?" Krüger smiled faintly. "Then the war would have been decided by science, not scarcity. But science starves here." He looked back at the glowing data plate. "Mark my words, Herr Hauptmann, in the future, wars will not be won by armies or generals. They will be won by systems, machines that measure, factories that think, and weapons that obey mathematics more faithfully than men." The wind outside rose, whistling through the broken shutters. Snow drifted across the window, melting against the warm glass. For a long time, neither man spoke. Finally, Vollmer said softly, "Then perhaps we never fought the Americans at all." Krüger turned toward him. "No," he said, "we fought their factories, and their factories never missed." The furnace roared behind them, casting long shadows on the wall, two men standing in the dying light of an age where genius was no longer enough, and where the cold, perfect rhythm of production had become the new heartbeat of war. The next morning broke grey and brittle over Kummersdorf. A low fog clung to the pine forest, muffling the sound of distant artillery. Inside the testing hall, a different kind of thunder began, the echo of steel striking steel. The technicians had mounted a captured American proximity fuse on a vibration rig, its circuits wired to a generator and oscilloscope. Dr. Helmut Krüger and Hauptmann Ernst Vollmer stood nearby, watching as the machine came alive with a faint hum that vibrated through the floor. "This," Krüger said, his voice nearly reverent, "is what they call an M403 proximity fuse. Radar in a bullet." Vollmer frowned. "Radar? Impossible. It's too small for an antenna." "That's what we thought," Krüger replied, motioning to the technician. "Begin." The technician turned a knob. A steady electronic tone filled the room, low at first, then rising in pitch. On the oscilloscope, a thin green line wavered, then sharpened into a perfect sine wave. Krüger leaned forward. "Inside this device is a miniature transmitter, a vacuum tube the size of your thumb. It sends out radio pulses, measures the reflection from a target, and detonates at the precise moment when the amplitude doubles. It calculates distance faster than any human could time a fuse." He turned toward Vollmer. "It means their shells explode, not when they hit, but when mathematics tells them the blast will be most lethal." The Hauptmann stared at the small metal cylinder, suddenly aware that it represented something far beyond technology. It was the embodiment of thinking made mechanical. "Our time fuses depend on calibration wheels," he murmured. "Wind speed, altitude, guesswork. They build fuses that think." Krüger nodded. "And they mass-produce them. The Americans have factories dedicated solely to assembling these thousands per day. Each component checked by electronic inspection. We cannot even copy one without breaking it." He lifted the disassembled fuse with delicate tweezers. "This is not just a weapon, Herr Hauptmann. It is a philosophy. They no longer trust men to calculate death, they trust circuits." He set the fuse back on the table. "You asked yesterday whether the metal chooses sides. Here is your answer. The metal listens to the laws of physics. The Americans have simply learned to speak that language fluently." He turned off the generator, and silence returned, deep and heavy. Vollmer rubbed his gloved hands together. "We used to laugh at their equipment, heavy, clumsy, too complicated. But now I wonder whether simplicity was ever an advantage." Krüger smiled faintly. "Simplicity is for those who can afford to lose." He walked to the wall where charts and graphs hung side by side. Comparative detonation patterns, shrapnel dispersal angles, statistical kill probabilities. "Look here," he said, pointing to one diagram. "Their airburst patterns overlap perfectly at 30 meters altitude. Each fuse corrects itself, adjusting for air density and speed. Our shells, even when set to time, vary by entire seconds. A delay of 1 second at 700 meters per second means a miss of 700 meters. 700 meters is the difference between a crater and a massacre." He stepped back, staring at the data. "This is the sound of their precision, Herr Hauptmann, not thunder, but harmony. Each explosion tuned like a note in an orchestra. Every gun part of a symphony, every fuse the percussion of an industrial mind." Vollmer sat on the edge of a table, eyes distant. "And we are what then, the old musicians? Playing from memory while they perform by metronome?" Krüger gave a tired nod. "Exactly. They compose war like music. Each salvo has rhythm, spacing, timing. The mathematics ensures no note is wasted. We improvise, they conduct." The technician handed him another report. "Herr Doctor, we completed the shrapnel pattern analysis." Krüger scanned it quickly. "Average fragment velocity, 900 meters per second. Dispersion radius, 32 meters. Efficiency, 95%. He looked up. "Our equivalent shell reaches 75%. It means their explosions kill more per kilogram of explosive. Even destruction has been optimized." He placed the report down and looked toward the window, where fog blurred the horizon. "You see, Herr Hauptmann, this is not merely an arms race. It is an evolution of thought. They have merged engineering and warfare so completely that even chaos now serves order." Vollmer exhaled slowly. "You make it sound inevitable." "It is inevitable," Krüger replied. "A war between precision and improvisation always ends the same way." He walked toward the test rig again, tracing his hand across the cold metal. "When the Americans fire, each shell is a promise not of courage, but of certainty. When we fire, it is still a gamble. And the universe, Herr Hauptmann, always sides with the predictable." For a long while, they stood in silence, listening to the faint ticking of the cooling equipment. At last, Vollmer spoke quietly. "Do you think they understand what they've built? That these devices, these factories, have made war impersonal, mathematical?" Krüger smiled sadly. "Perhaps. But they also understand something deeper, that in war, emotion is friction. Remove it, and the mechanism runs smoothly." He picked up the proximity fuse again, turning it over in his hands. "This little thing contains every lesson we refuse to learn: standardization, precision, efficiency, and above all, faith in mathematics. They have turned intellect into ammunition." He placed it back down with care, almost reverence. If Goethe had written about war, he would have said that mankind's greatest tragedy is not violence, it is perfection without mercy. Outside, the distant guns began again, a slow, methodical cadence rolling across the horizon. Krüger listened carefully, counting the seconds between impacts. 3-second intervals, he murmured. Exactly 3. You could set your watch by it. Vollmer looked at him. What does it mean? Krüger's expression hardened. It means the Americans are firing by radar control. Every shell corrected by instruments before it lands. Precision has learned to hear itself. The two men stood together in the dim light, surrounded by the relics of genius and the evidence of obsolescence. The laboratory, once the heart of German ambition, had become a sanctuary for defeated intellects, men who understood too late that the future had already chosen its champions. As the last echoes faded into the fog, Krüger whispered to no one in particular, "They have made even thunder obey equations." And in the stillness that followed, the air itself seemed to hold its breath as though waiting for the next perfect, calculated sound of war. By early December of 1944, the wind off the Brandenburg forests cut like a blade through the walls of the Kummersdorf proving ground. The laboratories that once glowed with the fever of invention had fallen into quiet resignation. Shelves of blueprints gathered frost, the ink fading to the same grey as the sky outside. Hauptmann Ernst Vollmer arrived at dawn, his boots tracking snow into the drafting hall. He found Dr. Helmut Krüger seated at a long table cluttered with reports, fragments, and the skeletal remains of what had once been a 15-centimeter artillery shell. The physicist had not slept. His spectacles were clouded with fatigue. "You're still here," Vollmer said, stamping his feet for warmth. Krüger did not look up. "Where else should I be? The front is everywhere now." On the table lay a sheaf of papers marked Geheim, not for transmission. At the top of the first page was a heading typed in neat English, U.S. Army Ordnance Department, Ballistics Division, Aberdeen Proving Ground. Beneath it, in careful German handwriting, were Krüger's translations, equations, measurements, and graphs copied from captured documents. They left these behind outside Aachen, he explained. Test data for their new propellant charges. See this curve? Burn pressure versus time. Look how smooth it is, no spikes, no dips. Our own data looks like a mountain range. He traced the curve with his finger. They have achieved perfect combustion balance, not too fast, not too slow. Every grain of powder shaped and perforated for predictable gas release. Their scientists learned to make explosions uniform. That is the difference between precision and chaos. Vollmer picked up one of the spent shell fragments beside him. It was warm from Krüger's hand and smooth along its fracture line. "Uniform explosions," he said quietly. "It sounds like poetry written by mathematicians." "Exactly," Krüger murmured. "And poetry always wins against noise." He leaned back, rubbing his temples. "Do you remember the first months of the war, Herr Hauptmann? We believed physics itself was on our side. We built faster shells, longer barrels, sharper trajectories, but we mistook elegance for efficiency. He pointed to the American reports, turned efficiency into elegance. They made the mathematics invisible, like oxygen in air." Vollmer paced slowly along the table, reading the foreign numbers. "So this is how we lose, not by courage, but by calculus." Krüger smiled thinly. "By calibration, to be precise." Outside, the distant rumble of artillery drifted through the frost. Even from 200 kilometers away, the steady rhythm of American batteries could be heard, a kind of heartbeat in the distance. Krüger listened, counting silently. Every salvo spaced by exactly 5 seconds. "Do you hear that? 5 seconds apart, synchronized fire control across entire battalions. The mathematics of death conducted like a metronome." He turned back to his papers. "They have something called the SCR 584 radar director. It tracks shell bursts in real time and adjusts aim automatically. Machines correcting other machines. When a gun fires, the radar sees the shell's arc, compares it to predicted flight, and computes a new angle before the next shot. We still depend on spotters with field glasses." Vollmer exhaled, frost curling from his breath. "So the machines now aim themselves?" "Yes," Krüger said softly. And the men simply load. He rose from his chair and walked to the window. Beyond the barbed fence lay the snow-covered test range, littered with the skeletal outlines of abandoned prototypes. "We once believed the will of man could overcome limits," he said, "but nature is loyal only to measurement." After a moment, he added, "Do you know what the Americans have achieved, Herr Hauptmann? They have made war repeatable." Vollmer frowned. Repeatable. Every shot, every burst, every movement can be reproduced precisely. Nothing is random anymore. In our world, every gun is unique. No two barrels shoot the same. In theirs, every weapon is a clone. The front line is a laboratory. He turned from the window. When an American battery fires, thousands of calculations converge: temperature, humidity, propellant burn rate, barrel wear, wind drift, all fed through machines. A single shell represents the work of 1,000 minds. We are still guessing angles with slide rules and prayers. Vollmer stared at the floor. Then what remains for us to fight with? Krüger looked at him gently. Pride. And pride is not a weapon. He picked up the fragment again, holding it close to the light. I once believed physics was neutral, that it belonged to whoever understood it best, but I was wrong. Physics has a moral bias. It favors consistency. It punishes improvisation. The Americans learned to obey it perfectly. We tried to command it. He placed the fragment down with a sigh. And so, nature itself turned against us. The wind rattled the window panes, scattering snowflakes across the ledge. Vollmer broke the silence. The men at the front still believe the war can be saved. New rockets, new jets, the V-weapons. Krüger smiled wearily. Ah, yes. Miracles made from shortages. Even our rockets suffer from uneven fuel flow, rough welds, unstable guidance. Do you know what their engineers said about our V2 after the war will end? They will. Admire it, yes. But they will make it work. They will give it precision, not faith. He sat again, folding his hands. That is what this war will teach the world, that faith without accuracy is just noise. Vollmer took a deep breath. Then what should I tell my men? Tell them that bravery still matters, Krüger said softly. But tell them also that bravery cannot bend trajectories. The shell does not care who fires it. For a moment the two men sat in silence, the only sound the faint creak of the furnace. Then, from somewhere deep within the compound, a telephone rang. Krüger ignored it until an assistant entered, breathless. Herr Doctor, Berlin requests your final report for Wahrprüf wir. They want an explanation for the American advantage and recommendations for immediate correction. Krüger smiled thinly. Immediate correction? Yes, I shall give them one. He pulled a sheet of paper from the stack and wrote slowly, deliberately. The American advantage is not in caliber, nor chemistry, nor even in computation. It lies in obedience, the obedience of machines to their equations, of men to their measurements, of factories to their blueprints. They have achieved harmony between matter and method. We have achieved only mastery of neither. He signed his name at the bottom, handed the page to the assistant, and whispered, Send it to Berlin, and then burn a copy for yourself. One day, you will want to remember that we knew. As the door closed, Vollmer looked at him. That sounded like surrender. Krüger nodded once. It is not surrender to men, he said quietly. It is surrender to physics. Outside, the snow began again, falling thick and slow, muffling the sound of the distant guns. Each flake settled with mathematical precision, tiny, identical, and unstoppable, descending through the frozen air like the quiet handwriting of inevitability.